Good afternoon, JYNs. We are doing the lesson on 12.1, higher derivative. Now, basically for this unit, you need to know the rules of differentiation very well. So you need to remember your chain rule, your product rule, and your quotient rule. Okay, let's look at 12.1. Now, what you have covered so far is dy dx, which is also known as f prime x, and this is also what they call the first derivative. All right. Now, if you differentiate one more time from dy dx, you will get the second derivative. And we write it as d squared y over dx squared, or f prime prime x. And what is important to take note is that the second derivative is not the same as when you square your dy dx expression. So let's do an example. Given y equals to 2x squared plus 5. Okay, so if I find dy dx, okay, first derivative, I will have 4x. If I differentiate one more time, okay, notice how I write d squared y over dx squared. My answer will be 4. But if you were to square your dy dx expression, you will have 16 squared. So therefore, the answers for your d squared y over dx squared is definitely not the same when you square your dy dx expression. Right, let's move on to take a look at the work example. All right, this is the work example. So the work example give you a y function, and part A, they want you to find the first derivative, dy dx, and then after that, the second derivative, d squared y over dx squared. Part B, you are supposed to find the range of values of x for which the first derivative and the second derivative are positive. Now, this question you have already done in chapter 11. All right, it involves inequality. You will have to solve the inequality for the first expression, and then another inequality that involves d squared y over dx squared, and then you will have to draw a number line to combine the two range and then give your final answer. So let's see how the solution will look like. Okay, the y function is in quotient, so please use quotient rule. So remember quotient rule. All right, take note of the negative sign here. So this is the answer for your dy dx. All right, now when you want to find d squared y over dx squared, you have to start from the dy dx expression. So you apply quotient rule to your dy dx again. Now the second step is what you have learned. Take out the common factor 2x minus 3. and then you will get the answer for your d squared y over dx squared. Okay, so now let's look at the inequality. So if you want dy over dx positive, which is greater than 0, so you put the expression greater than 0. Now this is what you have learned. The denominator with the square is always greater than 0. So what we need is actually the numerator. Take out the common factor 2x. And then finally, your answer should be x greater than 3, x less than 0. So this is your first inequality. Okay. For d squared y over dx squared greater than 0, again, the expression greater than 0. Now, in this case, the numerator is already greater than 0. 18 is greater than 0. So the only thing I need to consider is the denominator must be greater than 0. So there is a cube here. When I bring the cube over, it will be cube root of 0, and that will give you 0. So the second inequality is that x must be greater than 3 over 2. So let's combine the two inequality onto a number line. And then the final answer will be the combined range, which is this part, all right, of the number line. So the final answer, x greater than 3. Okay. After that, the question asks whether when you square your dy dx expression, is it equal to the second derivative? So square your dy dx, you will have such a complicated expression. And then look at your d squared y over dx squared. All right. Are they the same? No. So therefore, they are not equal. All right, so that's the end of your 12.1 on higher derivative. So what you need to do now is to go to PN1, all right, and do the questions for PN1, and then come back to school to discuss is there any part of the video recording that you don't understand. All right, have fun and enjoy. Bye-bye.